Morning, sir.
Yeah, man, morning.
Sir, how the assignment then going on now? Come now, sit down.
Alright, so me there try post it a while ago, cause we need to get it sorted out. So you will see them. What I'm going to be doing is posting them and then messaging you guys to ask if you see them on the teams,
Oh,
so
okay.
so, so you can update me and let me know.
Oh, sir, so that means that one of them, the one who did for the online, like online quiz, that now about to do it, I'll just do like a regular
No
one.
man, it's going to be done online same way. It's just that I'm going to let you know when it's posted so you can go on and do it.
Oh, all right.
Mm-hmm. And All right, you finish writing where we can start answering the questions. Once look at question number one.
Sure, we did the last part.
Okay. Um,
Alright, so you can continue now.
Yes, you can continue.
all right, give me a brief moment. I'm going to deal with a student. All right, so paying attention to this question, we're gonna see if we can accomplish all of what is written here. Finding the where the graph is going to touch the x and y axis, if it does. Finding the stationary points and the interval for which the function is increasing or decreasing. All right, let's go. So one of the things that we can go ahead right to do is that for the x-intercept, occurs when y is equal to 0, and the y-intercept occurs when x is equal to 0. All right, so when x is equal to 0, that means y is going to be equal to 0 cubed minus 4 times 0. So this is going to be 0 minus 0, so that's equal to, so y is equal to 0. All right, so that means the y-intercept is going to be 0, 0. So you have 1 point is going to be 0, 0. That's going to be your y-intercept. And then we're going to look for our x-intercept. So when y is equal to 0, this means that we're going to get 0 is equal to x cubed minus 4x. Now common here is x, so we can factor out a x, so we're left with x squared minus 4. This here is the difference of two squares. So this can be written as x minus 2, and x plus 2. So in order to solve this, we can say either x is equal to 0, or x minus 2 is equal to 0, or x plus 2 is equal to 0. Which means that x is equal to 0, or x is equal to 2, or x is equal to negative 2. So these are going to be our x-intercept. So we already know this point from over here. So when y is 0, x is 0. So that means one of the intercepts is going to be 0, 0. Already did find that point. And then one is going to be 2, 0. And then one is going to be negative 2, 0. Because remember, this is when y is equal to 0. So when y is 0, x is 0, x is 2, and x is negative 2. So we have three points. But again, we did already found this one from over here. That is not to say that it's always going to be a case that the one that you find over here is always going to be repeated over here. All right, so bear that in mind. So this is your y-intercept. And these are your x-intercepts. All right, so we know the intercept. So right then and there, we know where the graph is going to touch the x-axis and the y-axis. One of the next things that we're going to look at is the turning point. All right, or the stationary point. I think they use stationary point here. Yes, the stationary point, which is the same thing as the turning point. No. Right? So note carefully, at the stationary point, dy dx is equal to 0, which means that the gradient is equal to 0. Remember, we got the equation that y is equal to x cubed minus 4x. So when we take the first derivative, which is dy dx, we're going to get 3x squared minus 4. All right, so we're going to get 3x squared minus 4. And then from here, we need to find the stationary point. So remember, at the stationary point, the gradient is equal to 0. So 3x squared minus 4 is going to be equal to 0. We're going to solve for x. So x squared is equal to 4/3. And then we take the square root of both sides. And this is going to be square root of 4/3. Now the square root of 4/3 I'm gonna write it as a decimal. Is going to be plus or minus 1.15. All right, so that means x is either equal to 1.15 or x is equal to negative 1.15. Now we know the x values of the stationary point. So these are the, the x values of the stationary point. So we now also need to find the y values of our stationary points. When x is equal to 1.15, y is going to be equal to 1.15 cubed minus 4 times 1.15. So y is equal to this is going to be negative 3.08. So one of your stationary points is going to be 1.15, negative 3.08. And when when x is equal to negative 1.15, and then y is equal to negative 1.15 minus 4 times negative 1.15. Y is equal to positive 3.08. So the next stationary point is going to be negative 1.15, positive 3.08. So notice what we know. We know the points where the graph is going to touch the x and y axis, and we know the turning points of the graph, right? So what we can do also is to identify the intervals where the function is increasing or decreasing. So I'm going to give you a little time to finish writing this, and then we look at that aspect. So remember, the function is increasing or decreasing. That means you can get a concave upwards or a concave downwards, or that's where you're going to find out where do you have your minimum points or where do you have your maximum points. All right, so that's what we're going to check on next. So finish writing this. Let me know when you're finished writing so I can continue. All right, so last class we spent some time looking at the second derivative test, where we made mention of, based on the second derivative, if we know that the second derivative is greater than 0, then we have a minimum point. If it is less than 0, we have a maximum point. And then if it's then if it's equal to 0, it can be a maximum, minimum, or a point of inflection. In a case where we cannot use the second derivative test to check to see whether it's maximum or minimum, we have to revert to the first derivative test. So what we're going to do is to do the second derivative. So this is going to be equal to 6x. But notice this is a function. This is not a value. This doesn't tell us if this is greater than 0 or not. So in a case like this, we have to go ahead and use the values of the turning point, the x values of the stationary points in the second derivative to find out if we get a maximum or minimum. So when x is equal to 1.15, the second derivative is going to be equal to 6 times 1.15. So that's going to be about 6.9. So since this is second derivative, x is equal to 1.5 is greater than 0, then the stationary point that is 1.15 negative 3.08 is a minimum. Is 6.9 is greater than 0. X is equal to negative 1.15.
Sorry, hello, man.
Go again?
I say it's on raw.
Oh, sorry. So when x is equal to negative 1.15, we're going to get 6 times negative 1.15, which is going to be equal to negative 6.9. So since the second derivative is less than 0, then the stationary point at negative 1.5, 3 is maximum. All right, so we're going to get a maximum. So with that information, with all of this information, we can go ahead and represent this on the graph paper. Because remember, what we're doing is curve sketching. So in order to sketch the curve, you're not given any domain values. So you're not given any values for x. Then you have to find the values for x, or the key aspects that you're going to use to sketch the graph. Remember, a sketch gives a general outline of the graph and not all the specific details. All right. So go ahead, write that off, and then we look at representing it on the graph paper.
Sure,
All right. Go again.
I'm gonna say wait, I'm not finish.
Okay. That's okay. All right, you finish now. Finish writing.
Yes, sir. Alright, go on. Yeah, I can go now.
All right. So we now need to represent this on the graph paper. All right. X, Y, 0. All right. Let us separate it as much as we possibly can. -1, 2, -2. It doesn't go all the way up to that, but we can just introduce it. 1, 3, -1, -2, -3. All right. Let's use a different color to represent the graph. One of the points of intersection is going to be 0, 0, which is the origin. So we know that 1 point is right there. 2, 0 and -2, 0. So 1 point is going to be here at 2, 0. 1 is going to be here at -2, 0. All right, so those are the points of intersection of the axis. Now we get one stationary point that is -1.15. No, sorry. 1.15, -3.08. So -1.15 is about here, -3.08. So that's maybe about down here. All you have to do is give an approximation of where it's going to be. And then one is, no, did I get it mixed up? Yes, I did get it mixed up. Sorry. So it should be over here. +1.15. And then the one that is negative is going to be up here. All right. And we did recognize, notice what we know. The point that is -1.153.08, which is this point, is going to be a maximum. And then this one down here is going to be a minimum. So what will your graph look like? Your graph would look something like this. One zone, turn here and go back up like that. So this would be the graph of the function y is equal to x cubed minus 4x. What I'm going to do for you as well, I'm going to use the GeoGebra software to work this as well, so you can see it, what it would look like All right, just give me a second. Let me load the GeoGebra software. This thing taking so long. All right, let me try the online version. GeoGebra Classic. All right, so y is equal to x cubed minus 4x. All right, so if you notice right here, let me just give you a little bit more. So this is what it looks like. Notice it, one intersection is at -2, one is at the origin, one is at 2, 0. One point of the maximum point here is where we have -1.15 all the way up to 3.08, and then this one down here is positive 1.15, negative 3.08. So notice the general outline of the graph does coincide with what we have. I mean, it's not going to be perfect like what is there, but that would be the general outline of the graph. All right, go ahead and sketch this in your book while we get ready to look at another question. So notice, without getting all the points from the graph, you are able to give a pretty good representation or a pretty good sketch of the outline of what the graph will look like. All right. All right, let's go ahead with this one. So we're going to go ahead right away. We're going to find the y-intercept. When x is equal to 0. All right. So y is going to be equal to 4 times 0 cubed minus 15 times 0 squared plus 12 times 0 minus 8. So y is going to equal to -8. So the intercept is going to be 0, -8. All right. Now, instead of trying to go ahead and factorize this to find all the x intercepts, it's best to just go ahead and find out where the turning points are, because in doing so, that will kind of better help us, to find out where these points are going to be. And it's quite even possible that there is no x-intercepts, right? All right, so find the first derivative. Dy dx is going to be equal to 12x squared minus 30x plus 12. So at the stationary point, the gradient is equal to 0. So that means 12x squared minus 30x plus 12 is equal to 0 because we're looking to find the stationary points. We can reduce by 6. So if you want to work with smaller numbers, we can write this as 2. So let me just write this here. Can divide through by 6. 2x squared minus 5x plus 2 equal to 0. All right. And then all you need to do is to go ahead and factorize this using, the factorization method. We would have looked at multiple times the factorization method. So we're going to find that either 2x minus 1 is equal to 0 or x minus 2 is equal to 0, which means that x is equal to a half or x is equal to 2. Now, these are the x values for the stationary points. So you need to go ahead and find the y values for the stationary points, which means that you're going to substitute each of these values of x into the equation. All right. So when x is equal to a half, y is equal to 4 times a half cube minus 15 times a half squared plus 12 times a half minus 8. Now what we can do here, instead of trying to just sit down and work through this, you can just easily well put it in your calculator and work it out so you can, have more time to do other things. So this is going to give us negative 21 over 4. So one of your stationary points is going to be a half negative 21 over 4. And then when x is equal to 2, y is going to be equal to 4 times 2 cubed minus 15 times 2 squared plus 12 times 2 minus 8. This is going to be equal to negative 12. Whoa, stationary point to negative 12. This is going to be a point that is way down there, but we can just, fix up the graph so that it's not too crazy. All right, look and see if there's anything that I need to clarify. And then we're going to continue, because one of the things that we need to do is that we need to find out what is the nature of each of these stationary points. Do we have a maximum or a minimum? What is it that we end up with? Second derivative test. We differentiate the function again. Notice when we differentiate the first time, we get 12x squared minus 30x plus 12. So this time we're just going to get 24x minus 30. So this is what our second derivative is going to give us. Notice again, this is a function. It is not, it's not greater, it's not a number to say it's greater than 0. It's not a number to say it's less than 0. And it is certainly not equal to 0. So we have to go ahead and substitute in the values of x from the stationary points. So when x is equal to a half, at x equal to a half is going to be 24 times a half minus 30. This is going to give us 12 minus 30. All right. So that's going to give us negative 18. So since now the second derivative is less than 0, then the stationary point that is at a half, negative 21 over 4, is a maximum point. All right, so we know that it's a maximum. When x is equal to 2, that means the second derivative at x is equal to 2 is going to be 24 times 2 minus 30. So this is going to be equal to 18. So since the second derivative is greater than 0, and the stationary point that is at 2, negative 12 is a minimum. Going to be a minimum point. All right, so clear to see that one gives us a maximum value, one gives us a minimum value. So in so doing, we'll get our maximum and minimum points. What I want you to do is to go ahead and take that off so we can, identify what is happening in terms of what will this graph look like. All right, let's see what this looks like on a graph. Not using much positive value. All right, so let's see what we're working with. So we know that the y-intercept is 0, -8. That means the graph is going to intercept the y-axis there. And then we have one turning point or one stationary point at a half, 21/4. 21/4 is the same thing as 5.25. No. So a half, -5.25. So it's going to be right here. And then the next one is going to be 2 -12. Oh, this one is going to be a narrow graph. 2 negative, oh, -12. Let's see. We need some more on the -10, -11, -12. So 2 -12 is going to get us all the way down here. So the graph is going to, so remember, we know that this one is a maximum, this one is a minimum. So we know that it's going to go up and then come down to this one and then goes back up. So this will be the general look of the graph. Somewhere in here, there is going to be a point of inflection. And you can actually find out the exact location or the exact point of inflection, right, by using the second derivative test. All right. So the second derivative is where you check to see where the graph is turning. Because remember, when the second derivative is equal to 0, you can get the point of inflection. All right. So all you're going to do is to take the second derivative, make it equal to 0. The second derivative we found was 24x minus 30. So we can say, since the second derivative, 24x minus 30, so it's going to be 24x minus 30 equal to 0. Solve for x equals to 30, divide by 24, divide by 24. X is equal to 6/5/4. So this is the x value of the point of inflection. All right. So we just find the x value of the point of inflection. So to find the y value, y is going to be equal to 4 times 5/4 cube minus 15 times 5 quarters squared plus 12 times 5 quarters minus 8. And then we just go ahead and find the y value. So it's 4. You can just use a calculator for this part. Minus 15 open bracket squared plus 12 minus 8. So we're going to get negative 69 over 8, right? So the point of inflection is going to be 5 quarters negative 69 over 8. That's where you're going to get the point of inflection. So it's going to be 1 1/4. So 1 1/4 is about here, and it's going to come down to negative 69 over 8 is negative 8.62. So it's about here, come down to negative 8.62. So maybe about right here. No. Yeah, maybe about right here. So this is where we're going to get the point of inflection. Now, the point of inflection, if you notice how it is, let me just explain what is happening with a point of inflection. So that's why it says at this point, it is neither maximum nor minimum. All right. So it is just the point at which it turns or it changes from being a minimum going into becoming now a maximum, or changes from being a maximum to a minimum or a minimum to a maximum. So notice this part of the graph right here would give you a maximum curve, right? But then it moves, it changes from being going into, from the maximum curve to now going into a minimum curve. So that is what is happening here, all right? So it is, this is where it changes the direction. So instead of just completing a maximum curve going up, coming down, it then changes somewhere here at this point to now representing that which is going into a minimum curve and coming back up. All right. So that is what happens with the point of inflection. So this is what your graph would look like. If we want, we can go to the GeoGebra and get a feel of it. Let's go. I'm gonna get a y is equal to 4x cubed minus 15x squared plus 12x minus 8. All right, here we go. Let's look at what we have. All right, so notice this turning point, negative 212, that's right here. The next point, which is a half, negative 5 point something, is right here. The y-intercept, notice the y-intercept is here at 0, negative 8, and this would be the turn of the graph. So notice it is like what we have, yes? So that is what you would get for your graph. All right, let me know when you finish writing so we can continue. Anybody still writing? Let me get 5. 5 minutes. Anybody still writing? All right, I'll take that as a no and then continue. All right, so what we're going to do is look at another question. Shortly, I'll appoint one for you to do for yourself to see, how much of what we have been doing you have assimilated. So let's see what this one is working with. So say for instance, so we're going to all right. So at the we can go ahead and find the y-intercept. One of the things that we won't necessarily do right away is like to say, okay, let's factorize this to also find the x-intercept. So we're going to the y-intercept is when x is equal to 0. So we're going to have y is equal to 3 times 0 to the 4th minus 4 times 0 cubed minus 12 times 0 squared plus 8. So y is going to be equal to 0 minus 0 minus 0 plus 8. 8. So the y-intercept is going to be 0, 8. So this is where the graph is going to cut the y-axis. All right. So we're good there. Now at the stationary point, the gradient is going to be equal to 0. All right. So we need to find the first derivative. dy dx is going to be equal to 12x cubed minus 12x squared minus 24x. And at the stationary point, the gradient is 0, so we get 12x cubed minus 12x squared minus 24x. So that's equal to 0. So one of the things that we can identify here is that we notice that something is common between all of these terms, and that is 12x. So if you notice here, we're going to have x squared minus x minus 2 equal to 0. This we can factorize easily using the factorization method. So this is going to give us x minus 2 and x plus 1 equal to 0. So either 12x is equal to 0, or x minus 2 is equal to 0, or x plus 1 is equal to 0. So which means that x is equal to 0, x is equal to 2, or x is equal to negative 1. So those are the values we're going to get for our stationary points. All right, so these are the x values of or for the stationary point. So we know all our x values, so we need to find our y values. Now, one of the things that we recognize is that when x is 0, we already know when x is 0, we're going to get 0, 8. So we know that one already. So the next thing that we need to do is to find out when x is 2 and when x is going to be, when x is negative 1. I'm just going to use my calculator to work that out. Get negative 24 for the stationary point. This is going to be weights. I wrote a 2 here. So this is going to be 3 plus 4 minus 12 plus 8. So that means the stationary point is going to be negative 1, 3. All right, so we have, and we can just write it over here when x is equal to 0, y is going to be equal to 8. So the stationary point is going to be 0, 8. So we have 3 stationary point or 3 turning point. It just so happens that the y-intercept is also a stationary point. All right. So we can go ahead now and find out where do we have the maximum, minimum, so on and so forth. All right. All right. For this one, I'm not going to find out the point of inflection for this one. So I'm just going to second derivative. This is going to be equal to 36x squared minus 24x minus 24. But this is going to be our second derivative. And all we need to do is to substitute in the points when x is 2, when x is negative 1, when x is 0. All right. So when x is equal to 2, the second derivative, I'm just going to use my calculator to work it out instead of doing them very long. So this is going to be 36 minus 1. So this is going to be equal to 72. So that is greater than 0. So we're going to have a minimum. So this point, so the stationary point that is 2, negative 24 is a minimum point. When x is equal to negative 1, the second derivative we have 36, 24. So we're going to get 36. So this point, the stationary point that is negative 1, 3, is going to be a minimum. And when x is equal to 0, the second derivative is going to be equals to negative 24. So that means the stationary point, which is 0, 8, is going to be a maximum. So take this off, and then we're going to look at how to represent this on the graph paper. Well, not the graph, just a sketch of it. And then what I'm going to be doing afterwards is ask you to try a few of the questions for yourself. We may look at a few more questions on rate of change. I noticed that some persons were having an issue with questions on rate of change. So after we finish this question, I'm going to give you one for you to try for yourself, and then we'll look at some questions that involve rate of change. The next time we meet for class, we will be looking at integration. All right. So what you're going to find happening is that your assignments will be uploaded this week, and when it's uploaded onto the Moodle platform, I'm going to be messaging you to check and find out if you're seeing it there, so that you can let me know if you're seeing it or not. And then once it's there, you just take some time to work on it and get it done, because if you will recognize that we're getting close to the end of the semester, right? So please to bear that in mind. So go ahead and finish writing, and then we're gonna look at one for you to do it for yourself. All right, so we're gonna go ahead and see what this looks like on the graph now. What I'm going to do, I'm just going to plot the points, not rule it up like say I'm ruling up a graph paper, because one of the points go all the way down to -24. So I'm not going to do it as if I'm ruling up a graph paper. All right, X, Y, 0. So 0, 8, I'm gonna say it's about here. Hold a second, let me use a different color. So 0, 8 is about here. -1, 3, I'm going to put it at about here. And 2, -24. Let's say that point is about down here. So that's -2, no, 2, -24. All right, so we had said that this point was a minimum, this was a maximum, and then it's going to go down to this one, which is also a minimum. So this is what your graph would look like. So this is a maximum point, this is a minimum point, this is also a minimum point. So your graph would look like this, and this is the graph of y is equal to 3x to the fourth minus 4x cubed minus 12x squared plus 8. So this is what your graph would look like. Go ahead and take that off, and then we look at another. I'll give you one for you to try, and then whatever time we have left, we look at a few questions on rate of change. All right, so number 4, you are going to do this one right now. So I'll give you about 10 minutes to work on it. So go ahead with this one, please. Mhm. All right, so let us see where we are. All right, anybody finish? Anybody finish? Not hearing from anybody. All right, so I'm going to look at it and see where we're at. So the y-intercept is when x is equal to 0. So that means y is equal to 2 times 0 cubed plus 0 squared minus 8 times 0 minus 4. So y is equal to negative 4. So 0, negative 4 is going to be the y-intercept. Take the first derivative. So this is 6x squared, 2x minus 8. And we know that for the second derivative, we know the gradient is equal to 0 at the stationary point. All of this is divisible by 2. So we can write this as, by 2. 3x squared plus x minus 4 equal to 0. All right. So the factors of, can factorize this, the factors of negative 12, that will give us positive 1. So we can say 3x squared, 4x minus 3x minus 4, 0, x, 3x plus 4, minus 1, 3x plus 4. So x minus 1, 3x plus 4 equal to 0. So that means either x is equal to 1 or x is equal to negative 4/3. So these are the x values of the stationary points. Now we need to find the y values. So when x is equal to 1, y is going to be equal to 2 times 1 cube. All right, plus 1 squared minus 8 times 1 minus 4. All right, so we can just use this information. So once this is negative 12, so this is going to give us negative 9. So the stationary point is going to be 1, negative 9. When x is equal to negative 4/3. Y is equal to 2 times negative 4/3 cube plus negative 4/3 squared minus 8 times negative 4/3 minus 4. So I'm going to check this one and just use a calculator to do it. All right, so these are your two stationary points, and what we're going to check to do now is see which is maximum, which is minimum. When x is equal to 1, the second derivative is going to be equal to 14. So the stationary point, that is 1, negative 9, is going to be a minimum. And when x is equal to negative 4/3, the second derivative is equal to 12 times negative 4/3 plus 2. So this is going to be negative 14. So the stationary point, that is negative 4/3, 100/27, is going to be a maximum. All right, so this is going to be a maximum point. So now that we have all of that information, we can go ahead and represent it on the graph paper. All right. All right, so this is what your graph would look like for this function. Anybody got this for their answer? Anybody got this for their answer? All right, not hearing from you, so I'm not sure what's happening. So what we're going to do then is just move on. Remember, 100 divided by 27, this is about 3.7, thereabout. So that's why I see it's not exactly at 4, it's about here. So that's about 3.7. So it's not exactly 4. All right, so what I'm going to do, just give you about a minute or two to finish writing here, and then we're going to look at a few rate of change questions.
Nigga.
Repeat that.
No, sir, I know you my mic down mute by accident.
Okay. All right, so you bear in mind that we talk about rate of change when we look at the topic, and we talk about the fact that the rate of change has to deal with how fast something is changing over a period of time. All right. Now, if we're talking about a cube, right? Volume of a cube, let me use a different color. So the volume is equal to L cube, and the surface area is going to be 6L squared. All right. So that's what we're dealing with. Now it says a cube is expanding in such a way that the sides are changing at a rate. So when it says rate, it is talking about how fast it is taking place. So notice it says the sides are changing. So let's say we have a cube. Well, we have a cube, so the change in the length with respect to time is going to be 4 centimeters per second. Or you can see it written as 4 centimeters s to the negative 1. That's saying the same thing. All right. So this is how fast the length is changing, which is that the sides, the same thing as the length of the sides, right? It's changing at a rate. So it says that we are to find the rate of change of the total surface area of the cube when its volume is 216. So what we need to do is to find the change in the area. So the change in the area with respect to the length is going to be equal to 12L. So this is how the area is changing with respect to the length. Pay attention to something. Let us get something clear. Let us get something clear. It says we want to find the rate of change of the total surface area. So what is it that we want to find? We want to find the change in the area with respect to time. This is what we want to find. Let me just write it different. So want to find rate of change talks about how fast something is changing over a period of time. So we want to find the change in the area with respect to time. That is what this is saying. The change in the area with respect to time, because it asks us to find the rate of change of the total surface area. But one of the things that we can find out is that we can find out how the area is changing with respect to the length. So we know that, all right? And what we also need to do, we know how the length is changing with respect to time, all right? So what is it that we know? We know the area is changing with respect to the length, and we were given how the length is changing with respect to time. Bear in mind that they told us that the volume is 216. So 216 is equal to L cube. So that means if we want to know the length, it's going to be the cube root of 216 equal to the cube root of L cube. So that means the length is going to be equal to 6 centimeters. All right. So look at this now. Pay attention to this. The change in the area with respect to time, we can calculate it by finding the change in the area with respect to the length multiply by the change in the length with respect to time. Because when this cancels with this, we're just going to be left with dA over dt. So if we multiply these two rates of change, then we're going to get the rate of change of the area with respect to time. So what does this look like? The change in the area with respect to the length is going to be 12L, and the change in the length with respect to time is going to be 4. Right? So this is going to give us 48L. 48L. So this is the change in the area with respect to time. But it is specific to, notice, it is specific to find the rate of change. Wait, hold a second. So we get 12L. Okay, so, but it is specific. Notice it is very specific to when the cube has a volume of 216. So when the cube has a volume of 216, the length is going to be equal to 6 centimeters at that time. So when L is equal to 6, that means the change in the area with respect to time is going to be equal to 48 times 6, which is going to give us 288, and then centimeters cube per second. Why is it we have this units right there? This unit is there because of this language here. Find the rate of change. If it is a change, oh, my apologies. You notice what I write? I write cube, but it's area, so it must be squared. This is how fast the area is changing over time. So we are finding the rate of change of the area with respect to time. So the area is changing with respect to time at a rate of 288 centimeters squared for a second. All right. So the unit has to be there because you're calculating the rate of change. So that is the reason why you see it as 288 centimeters squared per second. That is it for rate of change. It is how fast the thing is changing over a period of time. All right, so we're gonna see if we can get in a few more questions, maybe this one and another one, and then I'll let you go for today. All right, let's look at this one. Now, it says it's a sphere. So the volume of the sphere is going to be 4/3 pi r cube. All right, so that's what we're going to get for the volume of the sphere. What is it that we know? We know that the spherical ball is inflating at a rate of 40 centimeters cube per second. Now, this unit alone gives us an indication of what is changing. Because it is cube units, we know that it's a change in the volume with respect to time. So that is 40 centimeters cube per second. So cube units is the unit of volume. So without telling us that it is volume, the units will help us to realize that what this rate of change is dealing with is volume. But one of the things that we know is that from this formula, the only variable there is the radius. So the radius can change. Pi cannot change. 4/3 is a constant. The cube is a constant because it's raised to the cube. So r is the only radius. So we can take the derivative of the volume with respect to the radius. So this is going to give us 4 pi r squared. All right, when we take the derivative of it. So what is it that we know? We know how the volume is changing with respect to the radius, and we know how the volume is changing with respect to time. They are asking us to find, notice what they ask us to find, the rate of increase in the radius. Now, if you ask about rate of increase in the radius, what is it that you want to find? You want to find the change in the radius with respect to time. So you need to know how the radius is changing with respect to time. All right, so that is what you're looking for. Here's what we know. If we take the change in the volume with respect to time, it's going to be equal to the change in the volume with respect to the radius times the change in the radius with respect to time. That is what this is equal to. So the change in the volume with respect to the time is going to be the change in the volume with respect to the radius times the change in the volume with respect to time. We know the change in the volume with respect to time is 40. We know that change in the volume with respect to the radius is 4 pi r squared. And then we want to find the change in the radius with respect to time. But we are mindful that they gave us some specific information. It says, notice the specific information is given here. It says we need to find the rate of increase of its radius given that the surface area is 200 pi centimeters squared. All right. So the surface area is 200 pi centimeters squared. So this information here will be replaced with 200 pi because they gave us a specific value. So the change in the volume with respect to the radius is going to be, given that the surface area is 200 pi centimeters squared. So they already tell us what does all of this mean. All of this means is going to be equal to 200 pi centimeters squared. They already tell us. So we just have to now use this information to work out the question. So we need to solve for dr dt. So we're going to divide by 200 pi and divide this side by 200 pi as well. So we're going to get 1 over 5 pi centimeters per second is equal to the change in the radius with respect to time. If you want to rewrite it, so you have the dr dt on the right hand side. So the change in the radius with respect to time is going to be equal to 1/5 pi centimeters per second. So this is how fast the radius is changing with respect to time. All right. So one of the things that you have to bear in mind, what information you are given in the question, what information you have to find, and then with so doing, you can be able to work out the question. All right, right, that's all for now. As I mentioned, we'll do one more question. All right, so we're going right into this one. The radius of a circle is increasing at a rate of 2 centimeters per second. Find the rate of change of its circumference. All right, so let's write down two things. Circumference is equal to 2 pi r, and area is equal to pi r squared. Now, the radius is increasing at a rate, so the change in the radius with respect to time is 2 centimeters per second. Find the rate of increase of the circumference. So you want the rate of increase of the circumference. So you want to find the change in the circumference with respect to time of this circle when the area of the circle is 4 pi centimeters squared. So the change in the area with respect to the radius is going to be equal to 2 pi r. All right. So that's how the area is changing with respect to the radius. But they said that when the change in the area is equal to 4 pi. So they are saying that this is equal to 4 pi because the change, notice it says when the area of the circle is 4 pi. So that means the area. So the change in the circumference with respect to the radius is going to be equal to 2 pi. So let us look at what we get from this. The change in the circumference with respect to time is going to be the change in the circumference with respect to the radius times the change in the radius with respect to time. This is going to be 2 pi find the rate of increase of the circumference. So that's going to be 2 pi times so why did they set it up like that? Two pi times 2, so that means that we're going to get 4 pi centimeters per second. So the change in the circumference is this change the same as the change in the of the area with respect to the radius. Okay. So the change in the circumference with respect to time is going to be equal to 4 pi centimeters per second. So for every second, the circumference is changing at 4 pi centimeters. Now, bear in mind, the assignments will be posted in the Moodle, and I'm going to message you to confirm that you can see it. And then once you are able to see it, then you go right ahead to ensure that you complete your assignments on time. All right, so that they can be marked and possibly returned to you in a timely manner. Anybody have any questions at this time before we dismiss for today?
No, sir.
All right. So with that said, if there's nothing else, you're free to go. Take care of yourselves until we meet again.
Okay, sir.
All right.
No, yes, sir. Same to you.
All right, then take care.